There seems to be a little bit of a crisis going on at ETH headquarters. And that crisis is basically their numbers not going up. Yeah, they're not making loads of money, and they're upset that the Solana boys are making loads of money, and now they're pointing fingers and blaming people and getting, quite harsh on Twitter. And they're having a go at the foundation. And I think that this is actually a very important topic because I always take issue with foundations because they're totally, centralized. And it's like, frankly, if your cryptocurrency requires governance, it's broken. Yeah, cryptocurrency governance is oxymoronic. It's like gold doesn't need to be governed. An objective item doesn't need to be governed. It should just be, and then everybody should just be able to do it, which is why I take issue with the ETH Foundation. And I think what's more interesting is that everybody loved the ETH Foundation at the beginning, yeah, with Vitalik at the top when he was funding the development of Uniswap. Yeah, they paid for that. And, when they were funding the initial writing of the ENS system and when they basically sprayed money on thousands of dev teams and they managed to get out, 4 or 5 really nice little protocol things that worked on Ethereum and blah, blah, blah. Value of ETH went up. Everybody loves it. Everybody's so happy. Oh, we love it. And now the numbers not going up, they're like, we hate you. You haven't done what it is that you need to do to make us money. And it's like, that's totally the wrong attitude. Yeah, it's not up to the ETH Foundation to make you, money and this and all of that. It's up to you, or it should be. That's the point about these decentralized environments. And now, unfortunately, it can't, so they're saying that you need to burn your funds. You should shut down. We're so annoyed. We're so angry with you for not having done what we wanted you to do. Yeah. And you've got all these nerds on Twitter who frankly don't know anything about anything going, this is what you should do with your $1 billion capital. You should do this. And then it's like, what do you know about it? I mean, if you ever run $1 billion org, you have no idea what the pressures and what they're trying to do and understanding of anything at all. And so, nobody knows what they're doing. And even Vitalik's getting a bit annoyed, which is quite interesting to see, actually. He's always a very, very calm, but he's actually losing his temper a bit, which is like, come on, you can get passionate about these things. But they can't withdraw now because they own everything. They run everything. They run all the servers that back up MetaMask. They have their fingers in every pie. And I think this is a classic example of centralization being a one-way street. Yeah. And once you go down that road, it's impossible to reverse track. You simply can't change from that direction that you're going in, where everything becomes centralized around a few bodies and around a few institutions to, no, actually, now we're decentralized. Because it's interesting because what they're basically, all the ETH boys are basically saying, yeah, we're much more decentralized than Solana. Yeah, that's why we're going to be good. It's like, kind of, you know what I mean? Just you're both as bad as each other. You're both terrible. But if that's the levels of what you're having to espouse to say why you're better than someone, I think you've got problems, lads. Yeah. So, frankly, I think it's I'm not sure that this is an intractable problem, and I'm not sure they're going to come up with a fix with it. But it is, it is something that some of us have always felt is a problem. You can't have these foundations. You can't have these central bodies governing your cryptocurrency. I mean, looking at, I'm going to talk about something else after this, but looking at our current setup, I do rant about this and how somehow we need to extricate ourselves from this situation. You can't be relying on Minima Global. It needs to be outside of us. Like, we're too small, frankly, for it to become, we're not large enough. We don't have enough money. We're not powerful enough. We are in our little ecosystem. We're not like, a foundation with billions of dollars doing stuff. But this applies to everybody. This is exactly the same thing applies to Solana, even though they're all sitting there sniggering. And exactly this applies to every other coin, frankly, Cardano, especially with Hoskins, except Bitcoin. They've managed, Satoshi did this. He managed to do this. He managed to get out. And how to extricate yourself from these situations, it's not simple. There's no easy answer to this. It's like, he basically just one day got up and left and everybody just got on with it. And that's really, really hard to do. So anyway, shout out to the ETH boys. I hope you can sort this out. We are all in this together, and I don't want destruction and death for the lot of you. I'd actually like you to be doing quite well, but I can tell that you're having a bit of a rough time of it at the moment. So that's what's happening in the ETH world. So good luck to them. The other thing I'd like to talk about is we've got this meeting with this company that does the decentralization metric. I think they call it the Nakamoto coefficient. It's like, how decentralized are you? Because this is really, this is the metric that counts. How decentralized is your chain? And they've got lots of different ways that they check this. And one of them is like, well, how many developers work on your code? It's like, oh, we're not doing well on that one. And how many clients do you have? And it's like, well, and how many users do you have? And how many dApps do you have? And how many successful these do you have? And, there's lots of metrics that they stick together to see. And then they come up with a number and they say, this is your NACA, this is how decentralized you are. And all I'm going to say is that all of those metrics don't matter. Yeah, because all of those metrics are based, and all of those metrics only come to matter if your initial base chain is decentralized. As I mentioned earlier, centralization is incredibly pernicious, and once you start down that road, it is a one-way street. And if your tech centralizes, if it has that crack, yeah, it only gets bigger. And so it doesn't matter how many devs you have writing your code and how many clients you have, like Ethereum, and how many of these applications you have, if your base chain centralizes over time. Yeah. So it's like, they're saying, yeah, Ethereum's got 3 clients and it's got this many devs and it's got this many users. And, these are really good things for decentralization. It's like, that's all fine and that's all cool, but it doesn't matter if the base chain centralizes over time. And this is the funny thing, because this is the one thing that Minima does that none of the others do. Every single other chain, the larger it gets, the more centralized it gets. Doesn't matter how many devs they've got or how many clients they've got or any of that. Whereas the larger Minima gets, the more decentralized it gets at a base level. Yeah, because that's how our protocol works. The Minima consensus is a decentralized consensus protocol. With no centralization, no incentives to centralize. Whereas all the other chains, the proof of stake chains, the proof of work, miner-centric chains, do have an incentive to centralize. So there's nothing you can do on top of that. You can't fix the foundations by adding another floor to your house. Yeah, it's like, we've got 2 different teams now with 2 different clients, and it's like, it doesn't matter, because your base chain just centralizes over time. 10 years from now, there's only going to be one validator doing everything. And so I think that's interesting. And this is the problem that the Ethereum Foundation and Ethereum are facing, and that Solana are facing, and frankly, everybody's facing. Even beautiful Bitcoin will have to face this issue at some point. I continually see posts about how they're going to tackle the centralization of mining, and none of them come up with an answer. None of them are actually, the word that they use now is the diseconomies of scale. Yeah, so we've all heard about economies of scale. When a business gets bigger, it gets cheaper stuff. Yeah, I'm a bigger player. I can now buy stuff cheaper, so I now get better advantages. So then I can get even bigger, faster than you. So this is the economies of scale. Bitcoin doesn't change this. It's an industry. This applies to it just as much. And so that means that I'm just going to get bigger and badder than the rest of you. And the only way we know of fixing that issue is by a monopolies commission, with regulation. We break up the companies once they get too big, and regulation breaks cryptocurrency. Because if you're going to regulate it, then why bother doing what just regulate at the beginning? If so regulation isn't allowed, otherwise your chain's broken. So now they're saying, it's the diseconomies of scale, isn't it? Because you'll be able to get electricity cheaper in all these places. And this means we're always going to have these factors. But like, this economies of scale applies to oil, applies to gold, it applies to everything. And these industries are centralized, and they have just as, they have a disparate selection of places across the world where you can get this stuff. And it hasn't made any difference on that. So why should it make a difference with cheap electricity? You're still going to get America and Russia against each other. And then the attack isn't, as I've mentioned, the attack might not be destroy the chain. The attack might not be full censorship. It's just like, well, I'm just going to delay your transaction. Yeah, so I'm just going to make it so you don't get into the blocks until we say, 10 minutes, an hour later. That's an enormous advantage. Imagine having the power to delay the transfer of money from one country to the other. Why would I use them when I can use you? Your business is faster. I'll use your business. Yeah. All the people who don't care about the tech are just like, look, I can send the money faster here than here. Then again, that'll centralize. Yeah. So there's lots of advantages to having the hash rate and the hash power in your country versus another country. And I just don't buy this economies of scale as a factor, and I hope it works. I hope that they can come up with something, but I have not heard anything yet, other than the way that Minima does it. Yeah, that's the only way. You're not allowed to have that, because Minima doesn't incentivize that. You don't get paid for that. It's impossible for somebody to acquire the hash rate required to do that, because you don't get paid to do it, and so there's no reason to do it. Minima has that pulse. we all do a little bit of work and it all sticks together. And it's just like, I still haven't seen that anywhere else, which is, very odd. And sorry, so I'll finish this up and then we can get onto the techie stuff. And what I will say is, we're in a Trump environment now. This is the first time ever that crypto is actually in a positive environment. This is the first time ever where we've got an SEC and the current rulers of the world, which are the American government, frankly, for all of us, whether we like it or not, they're pro. They're not anti. They're not coming for us. They're not trying to send us all to jail immediately. Yeah, you've got the president of the United States launching mean shit coins. Yeah, it's like, if he's doing that, what can I think we've all been given a pass. I think this is going to be a very different 5 years. Whether he gets another years, but this is going to be very interesting to see what we can do now. Whether when we're not throttled, when the whole industry isn't constantly battling this legal issue, no man's land, where nothing has been clear, there's been no honest regulation about any of this, whether we can now actually get on and do it. Look at what we've achieved against the tide. Now we're going to be moving with the tide. Now we're going to be, surfing with the waves, raising capital, ICOs, all of this stuff, which has been a complete nightmare because nobody knows whether they're allowed to do it and whether they're just risking jail if they ask for some money via a token, which is perfect, which is a really nice way of doing it. Yeah. Can I make an NFT and sell it and then use that? Can my pub, on a small scale, it doesn't have to be a large scale, can my pub, launch a token which will pay a dividend to see if I can extend the restaurant so that I can more people, hundreds of thousands of pounds, not hundreds of billions or millions, just small things. This is the point about this technology, that small people can use it to do small things. It's not always about the big boys. And that has been an absolute horror, since the beginning. And now we're reaching a stage where now we are in an environment where that might not be a horror. And I'm just like, wow, what can we achieve in the next 5 years given what we achieved before? And we weren't allowed to do it, when we had to be careful about it. And so this is a very exciting time. Yeah, this is going to be very interesting what happens in the next 5 years and what we can achieve. And I'm very much looking forward to, seeing where this goes. I think this is good. I think this is good stuff. Woo! And then last but not least, sorry, Nia, last but not least, I just got to do a quick dev update on Minima. It's so funny with Minima because it's like, we do keep tinkering and touching and and I do feel that we're getting to we are reaching stable state. Yeah, we're reaching like, wow, it actually works. It doesn't break. It doesn't crash. I'm not sure if everybody has the same experience of that. That's fine. But, generally, I never have any issues. That's different from anybody else I know because it's just me, and that's fine. But we are definitely reaching a good point with the tech. And it's like there's issues that we've had since the beginning that we fixed last week. We fixed something last week with the mini hub system that was grinding it slowly just because of the logs and something. And it's just fascinating to see how these issues are there. And it's just like, it's like, why didn't you fix it before? It's like, well, we had this big pile of stuff that we were fixing, and now we've actually managed to get to it. But we're getting to a good stage now. We're getting to the stage where it might be possible to actually step back a little bit, where it might be, I keep threatening this, not threatening, but I keep saying, if we want to do a Satoshi, and if we want to sort of say, look, we're going to freeze the mini global repo, and then we're going to fork, other people are going to fork it. And the reason that's good for us is because we don't have protocol changes. Yeah, we're the only coin that doesn't have any protocol changes. Yeah, or the only changes we make are to the client. The only changes we make are to the interface, to the protocol, which is a big thing. Yeah, it's a big deal. That means, look, nobody's going to change the protocol. That's actually working, and there's nothing we can do about that. But it would be nice to have a C client or a Python client or it would be nice to have a pure JavaScript client. I don't know, it'd be nice to be writing some different clients and some different stuff, whatever, from the base layer, as I said earlier, which is, correct in that it doesn't centralize. And, it's looking good, actually. I'm very happy with the way that the tech has come along. I wish it could have come along faster, but frankly, we're a small team. We're not a large team. We didn't have $1 billion to spend after our ICO, et cetera. We sort of had to chip our way here. But we're at a good stage now. So I'm very happy with the tech. I'm looking forward to the next 5 years. And, good luck to us all. Ooh, right, how am I doing? Here we go, Nia. That's it. That was a quick rant.
All right. Sorry, we thought it'd be better if you were alone on stage during your rant for the video.
Oh, it's fine, Nia. I don't mind you being here.
I stepped down. So this call is to interact with you people on the stage. I see a few questions coming in already. But
Tech questions, tough questions,
yeah, we need tough questions. Yeah. So Samuel, you're asking about the Minima DAO and governance. I think it's quite clear. Paddy has given us his opinion of governance, and I don't think Minima will ever have governance. So I think that answers your question.
Have governance. Gold doesn't have governance, does it? Nobody looks after gold, and yet we could all manage to use it for thousands of years without even knowing that other people were using it. You don't want governance. And frankly, Minima itself is the ultimate DAO, is it not? What I mean is put your money where your mouth is. Yeah, Minima is the money. And so where you put your Minima is where that is the ultimate vote. That's the only thing we have of any power, where we put our Minima. Minima itself is the DAO. With no restrictions, no limitations. I don't have to have a vote on chain. I can just give my money where I want to do it. Anybody can ask for money to do whatever they want, and they can get on with it. So Minima is the ultimate DAO. Minima itself.
I've also just enabled requests for you all to come up on stage. So if anyone would like to share or ask a question, just do that. All right, Fidzi. I can't raise my hand. Yeah, you should be able to now, Mantri. Fidzi, come up on stage. I've invited you.
Fidzi.
Hello.
Hi.
You're muted, sir.
Yeah, he's muted.
Well, I mean,
he's got the hand.
There's no point in coming up on stage.
What does that mean?
What? What? Okay. Goodbye, Fizzy. There's a question from Joshua. So prune. I mean, I don't really get it, but Joshua was saying prune the MMR system. Does Minima MMR servers do that pruning? What if somebody's coin is pruned? Is it lost forever from the MMR nodes of Minima?
Okay, so let's talk about the mega MMR nodes, which I think are quite cool, actually. So as you all know, you only store the data that is relevant to you. So on your Minima node, you don't have a database of everything. You have a database that just stores your coins, because why would I bother storing coins that don't belong to me, which I can't spend? And then when I send a transaction, I add the proofs of the database coins to the transaction so that everybody can validate that that is a valid transaction. The reason that's a really nice system is because it's lossless, as in we're not losing any information. There is just as much information in there as a proper database, but I only store the stuff that matters to me and you store the stuff that matters to you. I still validate everything when it comes in. I still check every transaction and all of that, but it's the ultimate pruning system. It's like a big tree. It's called an MMR, Merkel Mountain Range, Peter Ton, great man. And and you keep the coins of the leaf nodes, and then you have the Merkel branches. And what we come up with, which some of you may have seen, is before resyncing your node, doing a seed sync was a total nightmare, very slow, and you had to have this massive file that you had to download it, and it was just crashing phones, and it was just very, very bad. So we've come up with this thing called a mega MMR, which is a node which stores everything. Yeah, so you can have a node which actually does store all of the coins. It doesn't keep spent coins. It only keeps the UTXO, the unspent transaction outputs. Yeah, and so we call it the mega MMR because it has every single unspent coin still in the system. What's interesting about that system actually is that it doesn't actually have to grow. Yeah, because what happens as you have transactions is that certain coins get spent and certain coins get created. And so actually what you find is that you sort of come up with a constant size, and what the size of the mega MMR is proportional to is the number of users and the number of transactions. And if that stays the same, then frankly, the mega MMR stays the same. Even if you're doing hundreds of transactions a day, thousands of transactions a day, because you're spending some and creating others, and it gets rid of the ones that you spent and it adds the ones that you created, you actually find that you get a limited size, which is really nice. So we call that the mega MMR. And what it means is that you can now say, look, I want to resync. I want to just give me the coins that are mine. You can speak to the Mega MMR and it gives it to you. And the whole process of seed syncing now takes about 10 seconds, which is like beautiful. It's not that big. I run one on my Spartacus Rex server. It's really not that big a deal. It's currently it's about 180 megabytes. For us, 180 megabytes is a lot. Yeah, a Bitcoin does about 600 megabytes a day of blocks. Yes, 144 blocks a day. Each block is 4 megabytes. So yes, about 600 megabytes a day that they get through, and we're stressing about 180 megabytes, which I think is fair enough. You know what I mean? We don't want it. That is too big. But anyway, the Mega MMR is currently 180 megabytes. And now what we're finding is that actually you can be, because we've integrated with exchanges, yeah, which has been a great success. Frank, I'm very happy with the way that's gone. We've actually integrated with businesses and they've had to use Minima on a sort of critical level that can't crash, can't do anything. And it's been working very well. I hope you've all had good experiences with Bitmart and MEXC if you've been using that. But what you find is that they don't actually care about a lot of the coins. So they don't care about tokens for now, yeah, because they're not integrated with tokens. They just use Minima. So what if I went to my Mega MMR and I said, look, there's no need for you to keep any of the NFTs or any of the tokens or any of that stuff because the exchange doesn't need them. The exchange needs all the coins because it has all its users and it uses, some of you may not know this, but there is a whole slew of functions which are send, rather than send from the command line, you can say send from, and then you can give it a private key. Yeah, and you can actually construct transactions from any of the coins, not the coins that are part of the wallet of the node. That's how the exchanges work. That's what allows the exchanges to have millions of users all using a single node, which is also very nice. And so we've had to come up with ways of pruning the Mega MMR and what information do you want to keep and what information don't you want to keep. And that's also a very interesting topic. What I will say is that nobody has to do this. No one is forced to do this. If I'm running, my Mega MMR keeps everything. But if you want to have yours pruned, then you can. So what Joshua was saying, does that mean everyone's going to lose their data? Well, look, if I want to prune stuff from my Mega MMR, I'm allowed to. You don't have to prune it from yours, and he doesn't have to prune it from his. But if I want to prune it from mine, then that's none of your business, frankly. This is the point about decentralization, yeah? There is a record of every coin, and that is the MySQL backup. That's a different thing, and that's only about 500 megabytes now, 600 megabytes, I think it is now. So that's also not enormous, even though that's, to me, it's like 600 megabytes, but that's the current complete set of everything. I run one of those as well. And so you can always reconstruct the Mega MMR from the SQL backup. And we have those files on Spartacus Rex. You can download them. These are just helpful for the network. It doesn't cost me anything to do it. I do it because, I'm incentivized to do that because I hold Minima and I want Minima to work and I want people to be able to do, I'm not doing it as Minima Global, which is me. The processor power of my servers at like what 5%, 10%. I've always had a server online. I always have that stuff, so it's fine. So I just run it and I put them on the website and you can download them. So that's my incentive for running it. And you can always reconstruct your Mega MMR from that. But anybody can prune whatever they want. And there are now a whole slew of new command line parameters that you can add, like dash Mega MMR prune. You can prune any coin that has a state. Yeah, which I think is the one that Joshua was worried about because he likes embedding data on the chain, and that's fine. You can do it. If the chain allows you to do it, you're allowed to do it. I can't stop you from doing it. But you can now choose to have that information pruned from your Mega MMR. And in fact, for the exchanges, if you prune tokens and you prune transactions which have state, and so it just keeps the coins basically that matter to its million users, the Mega MMR becomes 20 megabytes. Yeah, which is like tiny, which is, for the complete set of all the coins of all their users. I think that's interesting. That's very small. So yeah, nobody forces you, Joshua. Nobody has to prune this stuff, but you can if you want to. Okay.
All right. Thank you, Patty. There's quite a few more questions. So one's from Cave Meese. How are we going to ensure that as the network grows and more desktop nodes and IoT nodes appear, there are enough relay nodes online to guarantee the connections? Is there a limit of 10 nodes per one relay node?
So we use the Java, very good question. So currently it is true that you need a relay node. You only need the relay node, I have to say, because you don't have an external IP. If you did have an external IP, you could be running it from your phone. Your phone doesn't have an external IP. This may change in future. and this may change it. And you know, I've had some very interesting chats with the chap who the IPv6 stuff. So IPv6 is interesting because IPv6 gives you an address, which is like a global address. Yeah. So you may have noticed those weird IPs, and instead of being four numbers, 255.374.funk, they're like F4, F5, E6, or E7. You know, there's six sort of double byte numbers. That's an IPv6 address. That is a global address. That is an address that, because you don't have your internal network NAT address and then your external address. And I think the goal of IPv6, you know, it hasn't taken over the web yet. Everybody's still using IPv4. You know, this is when stuff gets ossified into the base layer. It's very hard to get rid of it. So IPv4 is currently the ossified layer of the network, and we all use it. But when we switch to IPv6, you might actually be able to have an internal, external IP on your phone. So your phone will be able to actually receive incoming connections. So I guess what I'm saying is that the current network topology is not at all protocol dependent. Yeah, it's like that's just the peer-to-peer layer. How does the peer-to-peer layer go? And if we want to come up with a new one, we can. I'm actually in the process of rewriting the peer-to-peer. Number two is that there are solutions that in future may mean that you won't need any relay nodes, that you yourself will be an independent node on the network, which would be the best, you know, which is what we want. And so you won't be relaying through anybody ever. You'll just be, you know, I'll just be on the connection. This is my IP address, my IPv6 address, and you can just connect to me. And there are even other solutions like Keat.io, which is written by the guy who owns Tether, USDT, which is this sort of hole punch mechanism for NAT routers, which allows you to create a UDP packet transfer, even though you're behind NAT, which I really like. And that could be a solution. And what that means is that your phone can talk to another phone, even though you're both behind three different Wi-Fis. Yeah, so if I'm behind a NAT and NAT and NAT, and he's behind a NAT and NAT and NAT, we can still communicate directly to each other using this hole punch technique, which basically, it's a hack though. It tricks the router into thinking it's an outgoing connection when in fact it's an incoming connection. And you still need to meet up somewhere to initiate the connection. But once the connection's initiated, you can then talk directly to each other. I'd love that as well. And these are like P2P things. It's got nothing to do with the Minima protocol. You know, the Minima protocol is transparent to that. It doesn't care. It just wants to flood fill a message across the network. So if we rewrote the P2P to use that, that would also fix the issue. Yeah. So what I'm saying is I think this is a temporary thing. What I will say as well is that the Java Minima jar uses the NIO, and I have seen boxes way back when on 98 when we had issues and people were connecting, which have 10,000 connections. So it's not like we're, you know, you can have a lot of connections. I don't think you should have 10,000 connections because clearly sending that amount of data would be slow. So I reckon you could probably have thousands. You know, maybe you know, the NIO can handle 10,000 connections, but whether you want that for a healthy network is, you know, you don't want that. But there are lots of solutions down the road which will hopefully mean you won't need to relay through anyone and that this issue is completely fixed and it's not a problem. You know, flood fill networks have lots of different, you know, flood fill networks have a different, someone's trying to get in. Flood fill networks have a different topological requirement. So actually, that's all we need. And there are solutions down the road that will remove this dependency from Minima.
Thank you, Patty.
Good question.
I don't understand any of this network stuff. Like I understand a bit of the a bit of the dev stuff, but the network is like out of bounds for me.
We can replace that. Yeah.
There was a question regarding Minima and if the chain experiences a high load of transactions, can it have interruptions like Sol and Ton? And alongside that question, can the MMR, the Merkel Mountain Range technology that you use as database, be upgraded?
Okay, two separate questions there. So the first question about traffic load on the network. We haven't had an issue yet. When Joshua did his trick at about block 120,000, yeah. So about 10, what was that, about a year ago now, when he overloaded the network with lots and lots of messages, which was lots of fun at 3 in the morning on a Saturday night. The phones broke because the memory went too high, and so the phones broke, but the servers didn't. Yeah, the servers didn't. So we fixed that now. So we've changed all of that. So what I'm going to say is that we've not had any issues yet. Minima actually has had 100% uptime. There's never been a moment where the whole network has gone down. There's always been nodes running, which is really good because it means the network topology is resilient to these sort of attacks. As long as one node is running, the network continues to tick over, and because everybody's adding their pulse to the network, all that happens is that blocks become a little bit slower, and then it catches up, and then they become normal again, and then as people join, the blocks become faster, and then the network difficulty adjusts, and so you can see that in the blocks. So that's cool. Again, I think this is an issue that we haven't really had to worry about. I look forward to having so many transactions on the network that we have to start tweaking this stuff. We've run test simulations in Docker environments where I have this many nodes sending this many transactions and have yet to break it. It's never the same in a test environment as in the wild, but there's no reason technically, we don't have, Sol's got a particularly fast execution environment, which means that you can get deadlocks. When you're operating at a scale of 500 milliseconds to do a block or whatever it is that they're doing, 1 second, and clearly you can have issues across the network. We have a 50-second block time. You get the transactions, you process them. Computer scales, this is like ice ages. So I don't think there's anything fundamental that means, that doesn't allow us to have massive throughput on the network. So I would say no, there's no issues with having lots of transactions across the network that can break it. And then the second bit of the question, what was the second bit of the question? Can the MMR handle anything? What's really nice about
No.
the MMR, what was the question?
It was if it could be upgraded, like
No.
changed.
Okay. Because that's part of the protocol now, and so we have to live with it. And I suppose what I'm going to say is that there's other bits of the protocol that I'm like, I wish I hadn't done that. I wish I'd done this. I wish I hadn't done this, and I've done that. And it's like, no, it's too late now. You're going to have to live with it, Pat. And actually, that's also really good because what you find is that when you're not allowed to change it, and you have to use the systems you've got, you just get around it. You just think, okay, so I have to do this, and it's like, that's it, and then you just get on with it. But no, the MMR is now, which is just a tree, it's just a hash tree. It's like, can you upgrade a hash tree? Not really. It's not a complicated structure. It's just a load of hashes that hash each other up until a root. The clever bit is how you keep right hand side of the tree as it grows. So you basically get what the MMR gives you is a database where you have insert and prove. You don't have, you got insert and update. You got insert and update, but you don't get select or delete. That sounds quite, imagine having a SQL database where you can insert stuff and you can update stuff. You can't select the start and you can't delete. And so you can also prove the existence because SQL doesn't really have that. So you have insert, update, and prove, but you don't get select and delete. But it can grow to any size. We can actually, the theoretical limit to the number of inputs to the MMR is 2 to the 256, which is more atoms than there are in the sun. So I think we're all right. But you can put a lot of data in, and the proof grows logarithmically. So we can have twice the amount of data adds 32 bytes to a proof. So we're on about 1 million. So when we got about 1 million, that's 2 to the 10s. You have 320 bytes on your Merkel branch. But if I had 2 million, if I had 2 million, then I'd have to be 11 bytes. If I had 4 million, it's going to be 12 32 bytes. So it grows really nicely. It grows very small amount the more data you stick into it. It's a logarithmic growth. It grew quickly at the beginning and now it's growing really, really slowly. And no, I don't think there's a limit to the amount of data. We'll never reach that limit on the Mega MMR. Or your MMR will never reach the limit of the amount of data you can stuff into it. If I can just talk about that for a second, sorry, Neil. We've got this cascade at the bottom, So I don't know if you know how Minima works. We have a chain, like a normal proof of work chain. And then at the end of it, we have this thing called a cascade. And what the cascade does is that we can pour proof of work into it. We can pour as much work into the cascade, and it gives me a number, And what's nice about the cascade is that it also grows logarithmically. So even in 1 million years' time, the cascade will be, maybe twice as long as it is now. And it will show the amount of work that's put into it because of the way that because of the way that the Minima blocks have that super block level. Some of you may have seen, there's the level which you need to reach, which is the difficulty that the network says you have to get to. But sometimes somebody finds a block that's twice as difficult, even though it says, look, you need to find a block that's this difficult. And you say, okay, I found a block, but it's twice as difficult. It's like, okay, that's fine. It's as difficult as I need. But we'll remember this is a double block. And then somebody else comes along, and this happens half as often as the guy that found it twice as difficult, which is half as often as people find one that's a normal difficulty. And he says, I found one that's 4 times as difficult. And it's like, oh, okay, great, that's nice. So we'll keep that. And what we can do is we can discard the blocks in between the 4 times as difficult blocks. And the sum of the blocks that are 4 times harder is the same as the sum of the blocks that are twice as hard. There will be twice as many blocks that are twice as hard than are 4 times as hard. Yeah. So this is another thing that we used to discuss on Bitcoin Talk all the time. So, this is not just something that it was called POPOW originally. Yeah. Well, I take that back. I actually came up with it, and then there was a paper written on it called POPOW, which is proof of work, and they wanted to use it to prove work that had been done on side chains, so that they could give you the money on the main chain. They were like, well, how can you show me how much work you put into this? And they said, well, look, why don't we give them the whole chain? And it's like, there's too much data. Can you make it smaller? You can't add proof of work to proof of work. That doesn't work. Yeah. So they're like, well, how can I squash this amount of work into a smaller data set with the same amount of work? And this is what this does. It says, well, look, just take the double strength ones, which there'll be half of, and just give me that. And it's like, oh, I've actually got the same amount of work because I consider them to be double strength, but I've only got half as many blocks. Ooh. And this is on average. Yeah, it's not regular. This is like sometimes there's lots of them, sometimes there aren't loads of them. So it is an on average thing. But we use that for the cascade, and that means that the whole of Minima should never grow bigger than X amount, even a billion years from now. There is a limit to the size. It grows asymptotically to a level, and it will never get any bigger than that, which I really like. All aspects of Minima grow to a level. Oh, here he is. Hello, Billy. Hello, sir.
Hi, Paddy.
Hello.
I have to say, just before we go on, that there is some issue with this format, which is that nobody is willing to interrupt you, which means that it's the Paddy show.
No good. Yeah, that's no good. But how are we going to do what we need? We need a sort of interruptible format. I don't know. You tell me.
Yeah, because you're never going to interrupt yourself. You're never going to say, "Oh, I've finished that answer now," are you?
Right. No, you're right.
Yeah.
Well,
Neo's not going to interrupt you.
Aren't you interrupting me now?
It's difficult.
I've been trying for the last 39 minutes to interrupt you.
I love it. You're right, though. More interruptions, please. Come on. More interrupt requests.
Right. I have 3 very, very technical, and they can be very concise answers, because if this is being recorded, I will go back and look at what your answers are. Right. So the first one is, I discussed this with Jazz as well. I know that you discussed it briefly with Jazz too. Yep. But I want to make a game. So initially it was going to be a Go game or a chess game or something like that, where you can bet on the result, which means that each of the goes has to be a transaction. So the proof of concept for this is something like a noughts and crosses game, where both parties can and I sort of get the end bit. So how do you validate whether or not someone is a winner? Well, you can just say which of the grid references in a script. You can sort of say, like, if somebody has these grid references that mean that they have 3 in a row, then you can release the money to that
combinations of a tic-tac-toe board?
8. Well, there's 8 winning combinations.
What I'm saying is, what you could do. Okay, so this is one way of doing it. Just to say, how
can I just finish my question? Can I just finish my question?
Yeah,
Could you explain how it goes from? I understand that each go has to be a transaction, and then where does that transaction go? Is there a state variable that gets sent to a coin or a script? I'm struggling with the terminology and how it actually flows. How does the tic-tac-toe game flow, and how do we get to the end stage where we say, yes, you're the winner and you get the money?
Okay, I understand. So actually, all games operate on the same basic principle. And I don't know if you remember that lotto game I wrote, which was a simpler version of tic-tac-toe, which was just flick a coin. Yeah, you both
Yes.
flicked a coin, heads I won, tails you lost. Yeah, in the lotto game. But that's the same. It's a game. The game is flick a coin, and you need to run the game. I have to do a transaction, then you do a transaction, and then at the end it checks who wins and it pays out. Okay. Now whether that's flicking a coin or playing tic-tac-toe or playing chess or playing Risk or whatever it is, the process in my mind is the same.
Mhm.
You'd have to start the game where you both put money in. Yeah. So the game always starts with you both putting some money in. Everything is stored in a state variable, and all the updates are validated by a script. And so the script says, okay, I put money in, and the script can have a counter which is incremented every go. Yeah. And so it knows, okay, at the first counter, the first person has to put in some money. Check the amount. Okay, cool. Now we're at stage 2, which means the second player has to put money in. Okay, I checked that in the script. Yeah. You can have, the scripts are actually pretty small, but you could use master if you wanted to make a really, really big script. So all the data for the game is kept as state variables, and this is checked via the script. And then what happens is that when they play, yeah, like you don't need any random variables in tic-tac-toe, which is nice. On Lotto, I needed to have a random variable, which means that both players added a state variable, which was actually the hash of a random number. And then when it was their turn, they revealed the number, and the script checked that the pre-image was correct. It checked that when they hashed the random number you said you produced, it was the one that you had committed to in the hash. If you're looking at the Lotto script, we'll share that later and we can have a look at that. But the script has to be able to validate what's going on. And the memory mechanic is the state variables. No, you don't have a database like on Ethereum where you can just say, stick this in a database, but you kind of do. It's called a state variable. You can put any information you want in the state variable, and you can check that it is still there in the output. And so that the output, when it's used as an input, it goes like just imagine a state variable is just like, this is my memory. Anything I want to put in there. So for tic-tac-toe, you could just put a comma separated value with 0 is empty, 1 is a 0, 2 is an X, 2 is an X. You'd have 9 comma separated values. And you could actually write a script, substringed it up, that could check. I mean, there might be different, you might use a byte array, you could use whatever you wanted, but you'd have to say, this is the memory of the game. What round am I on? Whose go is it? What's the state of the
and
ball?
where is that stored? Is that in a state variable in the
state variable?
Yeah.
So
State variable, comma separated value. It's not 9 state variables. It's not each of the.
I mean, there's
just
many
one state variable
doing this, but I would probably keep the board as one state variable. And this is the board.
Yeah.
And then when I do a move, maybe state 3 is the value that I'm writing in. So the script would say, oh, he wants to put an X into square 3. Yes, so you'd have to say 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so I could say I want to put an X into 3. And so the script would have to say, right, is 3 empty? Make sure value 3 is equal to 0. And if it is, okay, I have to put in there. So this is the new. So how do I update the state? Here's the new board state. Yeah, I probably would use a byte array, a sequence of bytes, actually. That might be better. And so you're playing this game. And then at one point, just to say, what you want to be able to do is you want to be able to say, okay, how many different states are there in this game? Well, if you've got 9 squares, and each square can either be 0, 1, 2, you've got 3 to the 9, haven't you? You've got 3 squared, cubed, quad, quint. Yeah, so you've just got, if it was 2, you've got 2 to the 9, which is a very small number. Yeah, it's a very small number. So what that means is that you could actually come up with a Merkel tree. Yeah, this is how I would do, what you can do is you can come up with a Merkel tree. This is how I do my poker checking whenever I want to do my poker algorithm. So let's say, what is 3 to 9? I don't know, 2,000. Yeah, maybe 1,000. It's not a big number. And then you could say, right, here's a Merkel branch, which has all of the combinations that you can have in your tic-tac-toe board. And it also says, in this case, X1, or in this case, 0, 1, or in this case, thingy 1. And then this is the interesting bit, because the client can prove this. The client, and what you would do is you would put the root of that tree into the smart contract. And so at any stage, a player could say, hey, here's the current state of the game, and here is a proof from the Merkel tree that we built earlier, which you could build client side, yeah? So you provide the Merkel proof of the state of the game to the root, which the script can check. The script can say, has he provided me with a Merkel branch, which goes to this root? Okay, and is that state the same as the state that I've got? Yes, okay, it is. And that says that X1, okay, X1.
So it's more complicated. It sounds like it's much more complicated than just being able to update a script and then check.
If you're saying, would I work it out on the fly in script? For chess, you couldn't do this method because there's too many combinations. But for poker, for poker dice, for tic-tac-toe, the simplest way of doing it, I mean, I think this is the simplest way of doing it. You know, if you could write a script, if you write a script.
Surely the simplest way is just you have the winning combinations, of which there are only 8, and you just check whether or not the winning combination has occurred.
It's the same as that, but you put it all into a tree. Yeah, but I'm just saying there's only 1,000 combinations. Just build a tree which has got all the states. And some states it's like nobody's won this one. You know, at the beginning it's like 0, 0, 0, 0, 0, 0, 0, 0. Nobody's won this.
Sure.
When there's 1, 0, 0, 0, 0, and there's 0, 1, and there's 1,
so this
1.
means that then every single state can be checked against something in the tree rather than just doing
provide the proof of the state. You provide the proof, so the script doesn't have to do any looping or anything. The script just says, provide me a proof. So this is nice because all the computation is done off chain. You want to do as little as possible on chain. Providing proofs is like something that a client can do really, really easily. Yeah, but a script that everybody has to process is really, really hard. You only get 1,024 execution bytes. It's really hard to write a poker checking algorithm in 1,024 bytes. It's really hard.
Okay, I think that makes sense. I have 2 other questions. I thought I'd tell you them both, and you can say whether you want to answer either of them or both of them. So one of them is about DMs or chainmail or encryption and decryption in like on-chain messages that aren't using Maxima. So I want to introduce this to V, which is the new social media application, which is ready to be on the community app store, but isn't going to be on there until it's been vetted, I think. And the other question is
I'm writing chainmail at the moment. I'm writing chainmail.
So you're writing chainmail. Okay, so I'll just tell you the second question, then you can. I guess I can just put chainmail directly. I can just integrate it into Vox or V without just using the API, or I would actually integrate the code. I'm just going to ask my second question, and you can decide which is more interesting.
Sorry, go on. Sorry.
Second question. You talked earlier about the pubs and dividends and shares. I want to do that at a really simple level. Again, on Vox. I want to make it so that, for example, I can say to somebody, if you send me, so let's say I've got a business that's running on chain, and I want to be able to say something like, anyone who gives me 100 Minima is going to get one of my tokens, and it's actually a shareholder's token. So it means that you own 1% of my quote-unquote business. What is my business? My business is basically a wallet address, I suppose. And you imagine we'd have to work out how it's getting filled, but somehow a script or a wallet or a coin is getting money added to it. And I want to be able to verifiably pay out dividends from that pool of money to those people who have the tokens. So what's the most elegant way of doing that?
So I like thinking of it. I mean, there's obviously the whole digital way, but the funny thing is that that's 1% of the market. What about somebody who's running a pub? The way I like to think of it is that I have a local pub and they wanted to do an extension, and I'm like, why don't you ask us? Yeah, why don't you say, look, I need to make the restaurant bigger, so I'm going to make some tokens, and you're going to buy the tokens, and then every month I'm going to send 10% of the profits that the pub makes to the people who own the tokens.
Yes.
Capital. I want to raise capital. I need to have shares. You know, this is the original purpose of the stock market.
Like the old school way of actually raising capital.
Yeah, the old school way. So I need to raise some money. And the people who give me the money, I need to give them something. Instead of giving them a document, I give you a token. And then I can see who owns the tokens, and I can send some profits to those people. Now, mechanically, that you can almost see exactly how you would do that. You would write a little mini dApp, and the mini dApp, we've got this NFT marketplace, SoCo. I don't know if that's not quite public yet, but I think it's going in the beta store soon. So NFTs are sort of like that. You know what I mean? Imagine, you make 10,000 of these things and you sell them. And then can I tell who's got them? Yeah, it's perfectly possible for me to track everybody that has one of those NFTs. I can see the address that it's at. And is it then possible for me to cycle through that and to pay all of them in, 20 transactions, paying 50 of them at a time? Yeah, that's totally possible as well. So doing it on a mechanical level is actually pretty simple. I think the complexity comes in, when I speak to Jocelyn or when you want it all to be done on chain automatically without having to have anybody involved. But what you find is that 99% of businesses do have somebody involved. Yeah, I've got clients, I've got people giving me money, I've got this, you know what I mean? It's like, can I do it all in an automatic way so that people can just collect their money without me having to do anything? That's more complicated. But to do it in a sort of very simple mechanical way where I'm like, I printed 1,000 of these shares. I can see all the addresses because I can track those. Yeah. So I can see all the addresses that have any of those shares. And now I have a list of addresses here where those shares are and the amounts that they have. I don't know who, there's no name, there's no address. I don't even know if those shares
is there a way of the shareholders not relying on the person responsible for
you
giving out
have to rely on me
dividends?
anyway because I'm getting paid in the budget. I agree. Is there a way of cutting out the physical, manual, mechanical nature of it? That's more complicated. And you get into congestion issues. Yes, there are ways.
Could you do it more like a claim rather than so it's like if you've got this password, you can access money.
So they send a transaction saying, look, here are my coins. Please send me what you've earned this month. Looking at that address, I can tell that it's this much. In fact, yes. What I'm saying is you could automate it so you wouldn't actually have to do anything. And you could automate it so that they couldn't cheat. Yeah. And you could automate it so that they could see how much you're making. But I think removing your ability to just turn the system off and run off with the money is much harder. So you're incentivized not to do that because if you do that, then you won't be able to raise money again. Yeah. What if you wanted to raise more money?
Well, you're incentivized not to do that if you are a good actor. But if you're a bad actor, then you're incentivized to
again, I agree, but I also find that people get stuck up on this point, and it's like, look, why would I do that? I'm trying to raise money. Now I need to raise more money. If I run off with your money, I'm not going to be able to raise more money.
No, I'm not stuck on that because I think if you're actually doing it in good faith, which is the only way that I can imagine doing it and it being worthwhile, then the amount of trust you can build up by periodically paying out the dividend,
and you can raise even more money.
Is immense. Yeah.
Yeah, and when I say you, I don't mean you. I mean your public key. Yeah, it might be the case that you can build other structures on top of this. You can have people like due diligence is important. If somebody says, look, give me £1 million and I guarantee you I'm going to give you 2 million next year. And then he just runs off with the millions. Well, no offense, that's your stupid fault, yeah? Now, you need to be able to, you need to see what are you investing in? It's like, can I invest in you and make sure that I can't lose money and that you can't not give me the money that I give you back? No, that's not possible.
No.
I know that's how they do it.
You can build up a trust over okay, I get my dividends being paid out weekly for the last 53 weeks. I assume it's going to be paid out in the 54th week. I think that's fair.
And then it's like, here, guys, actually, everything's going really well. This is the yield you're getting. Because then, just to say, if there is a yield coming from the shares, if you're like, look, actually, you make this much money per share, that gives you a yield, that gives your share a price, that actually gives you a real price, you could sell more shares. Yeah, then you can actually, maybe you make 100% of the shares, you sell 10% of them, and you start paying out a yield to those. That's going really well. You've now got 90% left of those shares that you could then sell and pay out to those shares. Yeah, it's like a normal business, like the way it should be, rather than, it's like, yes, you could definitely do that. And it'd be a wonderful mini DApp, actually. Company 2.0, I always call it. Yeah, how would I do that? How would I raise capital, sell shares, and pay out dividends? A completely standard thing that everybody wants, like on a small scale. Like I'm running a club night up. I'm a student, and I'm running a club night.
Patty.
I think I'm going to do it with AI agents. There is the possibility of, if anyone's interested, if you want to answer this, if you'll allow it, Neo, I would love to hear about on-chain messaging because it's very relevant to the thing that I'm building, but I realize that I've taken lots of the time.
I'm going to finish it in about a week. I'll be finishing I've got Mini FS, Mini Web, and Chainmail. I've got 3 mini dApps that we're going to be releasing soon. which which allow you to publish zip files across the network, to browse those files
Oh,
in a
hello.
all of them at the same time. They look grim, but they don't look grim. I actually really like the stark, form that I like to operate
Do they look like you've designed them?
Yes. And then I've also got chainmail, which is unique because I want people to be able to communicate without having to be maxima contacts. Yeah. So how do I send a message? I'm on your website. You're selling me a T-shirt. MDS works. Yeah. So I can actually integrate sending and receiving money. And now I want to talk to you. So those three operate together. I see.
Why is chainmail more difficult? Because it must be, otherwise you wouldn't be spending time building it. Why is it more difficult than just a transaction where I've encrypted one of the state variables with a password that's relevant to you?
That's what it does.
Yeah.
It encrypts the
I
data.
think we're going to take a time out here because we're 1 hour in. Okay, so there's a few questions that may have been of interest.
Okay, Phil, good question. So we'll have to talk about it next time. But yes, wait until I show you chainmail, then you can be like,
thank you. Cheers, Neo. Bye, gang.
Nope.
Okay.
Sorry.
I'd love company 2.0
to
write that. That's a great mini app.
I think I mean, unfortunately, I wanted you maybe to cover these questions, but I think we're gonna end it here because we're 1 hour in, which is quite long. I just wanted to mention on our way out that we have a new team devs channel, which is basically where all the devs talk on Discord, and it is open to the public. This is normal, okay, for those of you that asked me. Basically, Patty and the dev team wanted to be more transparent about the day-to-day work. So feel free to check in, and if you want to ask questions, you can mention what we're talking about.
You can read it because it's more about this whole engagement thing, guys. We're trying to make you realize that we're just normal people like you. There's nothing special going on. We're not casting spells at the back here around bubbling cauldrons. It's like where's the JNLP file? How am I going to do this? What is that? Why is that broken? Normal dev tech stuff. But if you can see it, then maybe you can have a better understanding of what we're working on and what we're doing.
Yep. It's I think it's a cool addition. So, where is the dev channel? It's in the dev section of the Discord. It's let me find the category name.
No, it's not. It's
developers. It's just the category is called developers. That's where you have the dev chat. Ben would like to hear more about Company 2.0 in the future.
Yeah, good one.
So thank you everyone for attending. Patty, is there anything you want to say before we?
So it's just nice to a bit of banter, a bit of backwards and forwards stuff. Onwards, upwards. As always, love it. Love Minima. Love what we're doing. No critical issues yet, and let's see what we can do in this very different environment now. So let's see what happens. Interesting.
And there's just to say, there's a pretty major release normally scheduled for next week. So we think you will enjoy what we have to offer. Yeah. So thank you everyone. And see you
soon.
Bye-bye.
Thanks very much, guys. Thank you. Bye.